how they're working. Which one is working faster, you think? Yeah, you're right. Okay, yeah, this one is working faster. Okay, that's because I put two different solutions, okay, in both of these, right? One of them is a higher concentration of hydrogen peroxide, one is a lower concentration of hydrogen peroxide, okay? You get hydrogen peroxide in normal stores also, right? You know the percent of that? 3%, yeah, it is 3%, and that is not very harmful, okay? And even that they will tell you to store in a dark place, in a cool place, okay? Because after a while, it will die off, okay? And so this is a very strong peroxide, which you really cannot get anywhere commercially as such. We have to get it from our chemistry stores. And so this one is really 50% hydrogen peroxide, okay? And hydrogen peroxide is H2O2. And this is a reaction that's going on, okay, where we have H2O2 and the catalyst gives water and oxygen, okay? So the liquid that you see in there, okay, that is still water. The oxygen, did you see the smoke coming out? Now there was a smoke, okay, in this one. So that smoke that you saw coming out was actually oxygen, coming out so fast, okay, because it's a very hot reaction. If you feel this, she can, very good. It's warm, right? Okay. Yeah, it keeps getting hotter and hotter, right? Okay. So as it keeps getting hotter and hotter, that's because the reaction is going so fast over here. Okay, and so because it's going so fast, the oxygen and water, they all come as steam. Okay, and oxygen as well. Okay, you know where the bubbles are coming from? I did the trick right in front of you. I didn't hide anything in this one. No, the bubbles. This is the full one. Soap. That's it. Okay, if I didn't put the soap in there, you wouldn't see the beautiful action. Okay, all of this, you wouldn't see that. Okay, anyhow, are we good? Yes? Okay. All of this, okay, that I just mentioned to you is actually all about kinetics. Okay, and that's also something that we study in chemistry, is speeds of reactions. Okay, so what we do is we study how to make reactions faster, because if the reactions go at their own pace, then we can't reach out, okay, for the reactions to happen. So one of the things that we do is we look at these kind of different things and see how to make them faster. Okay, so one of the ways you can make reactions go faster is by the nature of reactants, which means whether something is a solid or a powder. Okay, so for example, when you okay, so let's see what happens over here. I should wear my goggles. Should have worn it before too, but anyway. This one's not moving at all, right? This one is almost completely gone. Obviously, what was in here was different than what's in here, right? Okay, so that was the magic, of course, but now you have to think about what was in the beaker.
Is it an acid?
Is it an acid? No, it is an acid. It is an acid. Are you answering?
Yeah.
Yeah.
Yes. Answering. No, it's not. I harassed you completely. Okay. Yes. Is it alcohol? It is alcohol. No, it's not alcohol. Okay, very good. But you're getting close though. You're getting very close. Because one of the things that we talked about before, and I'll bring up my demo here for you a little bit. This first one that I did really has a key point, okay? That translates to almost everything that we do, okay? And the key point was that water and ethanol dissolve so well together, okay? What happened here also? They dissolve so well, isn't it? Okay, and remember the styrofoam cup. It's so big, right? But see how much there is left in there? Not a whole lot, is it? If I take it out, it's just this much. Okay, which means what is the other stuff in there? Air. Okay, air. Which means that to make this styrofoam, you need just a little bit of material and a lot of air, okay, to go with it. That's how you make styrofoam. So actually what I have in here is acetone. Okay, and acetone is like nail polish. Everybody's like, oh, I can make that. All right, okay. Yeah, kind of like nail polish remover. So ethanol, you were getting close because ethanol is also an organic substance that would dissolve this. Okay, and so yes, this is water, which we're really thankful that Styrofoam is not dissolved in water, because then how would we carry our drinks, right? Yeah. So it's a good thing, all right, that it doesn't dissolve. But the problem with Styrofoam is kind of just what you just said, right? That it's not recyclable. Okay, so can you imagine all of this going in the waste container and just sitting there, So we have advantages of making polymers, okay, like sodium polyacrylate. Yes, it's a good advantage. But then we also have some, problems, okay, with polymers. One rule that we learn a lot in chemistry as we go on is like dissolves like. Okay, so if there are two things that are similar to each other, they will dissolve each other. Okay, so this is what polystyrene is, this structure, and that is acetone. Okay, so they have similar structures, as in they both have carbons in them, and so they dissolve each other. Okay, this one. Now, before we go on to this one, though, I wanted to show you one little thing more. Okay, to kind of show you how chemistry is coming along. Okay, so this is styrofoam. Okay, so this is also styrofoam. Okay, but I want you to see the properties of this. And this one, no mystery. I'm going to add water. Okay, to both. I need another brave soul. Okay, at the back. Come forward. Okay. So you can take this out and feel what it feels like. Nothing is going to harm you, otherwise I won't have you touch it. Okay. So yeah, got the good feel for it? Okay, good. Then go ahead and feel the other one now, this one. Does it feel the same?
No.
Is it getting squishy?
It's so much Cheetos in my mouth.
Looks like Cheetos too, doesn't it?
Yeah.
Okay, well take one and squish it. Take one and squish it. Is it squishing? Yeah. Does this one do that?
No.
No. So which means the properties are different, right? Thank you so much. Here, I hope you want me to wash properly? A little bit more? If you're okay? All right. Thank you. Okay, so she proved it for me. I didn't trick you or anything like that. But this one, see how it gets mushed up like this? These new peanuts or packing material that they're making now, these are biodegradable. Okay, and so these ones are the old ones, these old peanuts, which are not biodegradable. All right, so now they're trying to switch everything to something that is biodegradable. All right, and so the volume also will get less, because if you can squish something, then it gets less. Okay, in volume and space also. Okay, but whatever is coming out, did you hear that sound? That was out. Okay, so which means that we're getting towards better chemistry. Okay, now, and that's called green chemistry, by the way. Okay, as we keep going to better and better processes. Okay, so thank you. There is that. Okay, so the last one that I have for you, almost last, not quite the last, is this. And this is something that you have to count with me. And again, I hope it works. Okay, this is a reaction that works within 15 seconds. Okay, so we have to be good. You know what? I should have brought probably two of these. So, can I
Did you take a
first
big
the water? Yeah. Okay, so I'm going to take, I think this is exactly 500. All of this, well, then I don't need it, I guess, because it's exactly 500. So, there, okay. Okay, I'm supposed to put the stopwatch on, okay, but I'm not going to do that because it's kind of have to go out the link and all that stuff. So I want you all to count with me. Can you count 1
Yes.
through 15 at least? Okay. And relate to math. All right. So as soon as I mix, you have to start counting. If the reaction doesn't happen within 15 seconds, I pack up and go. Okay, then 20 seconds. 20 seconds. Then I pack up and go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16,
like they're bending down, right? They're always vertical. So the structure that's actually holding them together, okay, that's cellulose, and it's very, very strong. Have you ever tried eating cellulose, by the way?
It's in a lot of foods that we eat.
Cellulose.
Yeah.
Hopefully not.
I look at the label.
Oh, would you look at the labels? I would look at the labels
Look
too
at
now.
that.
Okay, I will.
The processed stuff.
Oh, the processed stuff.
Yeah.
Okay,
Not
all
like
right.
a vegetable, but like,
Yeah, but you can take a piece of potato and you can still eat it raw, and not that anyone's tried it probably. Okay, fruits you can eat. Okay, they're all carbohydrates. You can eat those. But trees, I would not recommend that you eat trees raw, right? Even cooked, okay, would not be that tasty. And that has to do with the structure, okay, of starch and cellulose. It's a very small difference. Can you note the difference between them? Yeah. Okay, here you can see all of these groups are on the same side. Here they are on the opposite sides. Okay, and that small difference makes a huge change in the body, and it cannot digest cellulose. Okay, so cellulose is actually a very good fiber. Okay, for your body. Maybe that's what you're taking. Am I telling you so? I'm sorry.
no.
No. Okay.
No, it's
All right.
food. It's food.
Okay. A lot of the fiber that you need to clean out, your intestines and all that good stuff, that is cellulose. Okay, starch is the good tasting one, and cellulose is not the good tasting. What do the cows eat?
Grass.
Cellulose. And thank God for that, so we don't have to fight for potatoes anymore. Okay. Okay, all right. One of the synthetic polymers is nylon, a very, very useful, okay, material. We don't even realize how much nylon we use. Okay, the ropes, okay, a lot of fibers. What is your bags made up of? Those are all nylons. Okay, but the reason I have it up here is because it was a very, very interesting use of nylon. So be ready for the prize here again. There is the magical question. So nylons were used definitely for rope. That's how it was discovered by DuPont. But what else were they used for? Raise your hand. This is the one for a prize. Yes? Pantyhose. Girl gets a prize. Only girls would know that, right? Yes, DuPont didn't know what to do with all of the polymer that they were making, so they marketed it to women. And before nylon came around, no, it was her. Right there, the lady there. Before nylon came around, or before nylon was actually synthesized, women were not required to wear pantyhoses. And actually they're called nylons. They used to be called nylons before. And suddenly DuPont came and made it mandatory for women to wear nylons. Okay, and so if you want to defy DuPont, put your foot down, say no nylons. Okay. What else are nylons used for? Strength, anything. Parachutes, the military later on used it a lot. Okay, when the World War II came around, because the discovery of nylon was just before World War, or just after World War I. So when World War II came around, then nylon really, DuPont got a real boost for production. Okay, let's talk about another polymer, which is styrofoam. Okay, so this is quite a fun one. And it's my water. You can put whatever you got at the top. That will. Okay. So I'm going to do a little magic here for you, yet again. Once a dud happens, you're always afraid. And if anything else is going to happen or not. Two liquids, do they look different? No. They're all the same? Looks like water? One has a little bit more? You want me to make it equal? Feeling happy. Okay, all right. So here we go. Styrofoam, anyone? Yes? Everybody knows what styrofoam is, right? Can you recycle styrofoam, by the way?
No.
Okay. So let's see what happens over here. I should wear my goggles. Should have worn it before today. This one's not moving at all, right? This one is almost completely gone. Obviously, what was in here was different than what's in here. key point was that water and ethanol dissolve so well together. Okay? What happened here also? They dissolve so well, isn't it? Okay. And remember the styrofoam cup. It's so big, right? But see how much there is left in there? Not a whole lot, is it? If I take it out, it's just this much. Okay, which means what is the other stuff in there? Air. Okay, air. Which means that to make this styrofoam, you need just a little bit of material and a lot of air, okay, to go with it. That's how you make styrofoam. So actually what I have in here is acetone. Okay, and acetone is like nail polish.